So this video is introducing the bubble method for balancing symbol equations, because this is a topic that lots and lots of students struggle with. Now, some of you may have done this with me in class before Christmas, but it's always nice to have a video to come back to go back over some of the examples. So from my earlier video on conservation and mass, here is the same equation again, but I'm going to show you how to balance this one using what I call the bubble method. So here I've got H2 plus O2 goes to make H2O. The first thing we do with the bubble method is we write out what we have. So H2 means I've got a H and a H. Okay, so I've got two H's there, and I'm going to put it in a bubble. O2 means I've got an O and an O, and I'm going to put it in a bubble. Then I'm going to put a little wall down here, because these bubbles can't go through the wall. Over here, I've got H2, H2O, water. So it's a H2, so it's a H and a H and an O. And I'm going to put that in a bubble. Now, the rule with the bubble method is you are not allowed to pop a bubble. You can only copy and paste a bubble that is there. So over on this side, I've got a H, and an O. So I've got two H's here and two H's here. That's fine. Don't need to do anything. Over here, I've got one O. Over here, I've got two O's. So following that idea of conservation of mass, that atoms cannot be created nor destroyed, what happened to the other O? So I can't have only one O on this side. So how do I get a second O? Well, I'm not allowed to just put an O on here by itself, because that's popping a bubble. So the only thing I can do is copy and paste a bubble that's already here. And the only bubble I've got to choose from here is this one. So I'm going to copy and paste and draw another bubble. So now looking at this, I've got two O's here and two O's here. Brilliant. I've now got four H's on this side, but only two on this side. So following that rule, we can't create or destroy atoms. I can't just take two away from this side, so I'm going to have to add two on this side. And it has to be two because I have to copy the bubble that's there. By doing that and rechecking, so now I've got 1, 2, 3, 4 H's, 1, 2, 3, 4 H's, 2 O's and 2 O's. That's now balance. I'm going to draw a line under that. So now what I'm going to do is I'm going to rewrite my equation. So if H2, how many bubbles do I have? 1, 2 bubbles. So a big 2 goes in the front. That's reacting with oxygen. I've only got one bubble there, so I don't need to write anything in the front here. That is going to make water, and the symbols for water is H2O, so I've not changed that, so that's good. And how many bubbles do I have? I've got 2 bubbles here. So I'm going to put a big 2 in the front like that. This is why it's important to write these equations down and handwrite them, because your 2's here are different sizes, and that's really difficult to do on a computer. So you need, this is one of the reasons why I want you to handwrite this piece of work. So that's the bubble method on one of the examples there. But I tell you what, let's be a bit sneaky and have a go at one of the ones in the tasks I've asked you to do. So here's one of the ones in the task I've asked you to do. I'm not telling you which task, because that's for you to go and work out. But let's do it together, just in case you're finding it a bit tricky. So again, with my bubble method, I've got H2. H2 means I've got a H and a H in a bubble. That's reacting with Cl2, chlorine. So that's a Cl and a Cl together in a bubble. I'm going to put my wall. And then on this side, I've got my hydrogen chloride. That's a H and Cl together. So again, following those rules, I need to count and see how many I've got. I've got one H there and 2 H's there. That doesn't work. Now I can't just put a H by itself. So here I have to copy and paste this bubble. So I am copying the bubble and writing it underneath like that. So now I've got 2 H's on this side, 2 H's on this side. Brilliant, H's are done. Got 2 Cl's here, and because I copied and pasted that bubble, I've got 2 Cl's there. So we're all balanced. Let's write out what we've got. H2 just one bubble, so we don't need to write a number there. Reacts with Cl2. Yeah, only one bubble, so I just need to copy that. And that goes to make HCl. But how many bubbles do we have here? 1, 2. So because we have 2 bubbles, we put a big 2 in the front. And that's now balanced. Let's do one more, just to check. This one's a little bit trickier. KNO3 goes to make KNO2 plus O2. Definitely not balanced. So let's write down what we've got here. We've got potassium, a nitrogen, and O3. 1, 2, 3. Okay, no. Let's put that in a bubble. We've then got the arrow, so I'm going to put my wall. Then we've got KNO2. So KNOO. Put it in a bubble. And O2, which is 2 O's in a bubble. So let's count it up. 1K, 1K, 1N, 1N. Right, it's the oxygens here we're having a problem with. And I can't just add one little oxygen here by itself. I've got 1, 2, 3, 4 oxygens on this side and only 3 on this side. So to make 4, at least on this side, I have to just copy and paste this whole thing. And put it in a bubble because we do not pop bubbles, don't break the bubbles. So now I've got 1, 2, 3, 4, 5, 6 oxygens. Over here, 1, 2, 3, 4 still. Now what I could do is just add some oxygen here, but actually something else is now unbalanced. My potassiums and my nitrogens, I've got 2 on this side, but only 1 on this side. So let's go back and rebalance those. And the only way I can do that is by producing another one of these. So let's have a look and see what's happened here. So 1, 2 potassiums. On this side, 1, 2. Right, potassiums are done. 2 nitrogens on this side. 2 nitrogens on this side. Nitrogens are done. Let's check the oxygens. 1, 2, 3, 4, 5, 6 oxygens here. 1, 2, 3, 4, 5, 6 oxygens there. We're all balanced. So we're going to draw a line underneath that. We're going to rewrite our equation. So we have KNO3. How many bubbles do we have? We've got 2. So a big 2 in the front, which goes to make our KNO2. How many bubbles? 2 and O2, of which we only have 1, so we don't need to write anything in front of there. Hopefully this is beginning to help make a bit more sense, but we'll do one more, just to check. So let's have a go at this one. Li plus O2 makes Li2O. Now, a lot of people wrongly think this one's already balanced, and that's because of this 2 here. They think it applies to the oxygen, but it doesn't. It applies to the element directly in front of it. So let's write this one out. We've got lithium in a bubble with oxygen, which is 2 O's in a bubble. Let's put our wall in. And we're making Li2. So that's 2 Li's and an O in a bubble. So first of all, we've got 2 lithiums here, but we've only got 1 over here. So let's start off by adding another lithium. Right, that's sorted my lithiums out. Let's start on the oxygens. 2 on this side, but only 1 on this side. So to make another one here, we have to use a whole bubble. We can't just add the oxygen. Are we done? Not quite. Our oxygens are fine, but by adding a whole new bubble here, we've now got 1, 2, 3, 4 lithiums. We've only got 2 over here. So we need to add more lithium. So let's check that. 1, 2, 3, 4 lithiums. 1, 2, 3, 4 lithiums. Done. 2 oxygens, 2 oxygens. Let's draw a line under that then and rewrite the equation. Lithium, 1, 2, 3, 4. Now remember, when we're balancing equations, we use the big numbers. We're reacting that with O2, which there's just one bubble there, so we're just going to write it as O2. And that goes to make Li2O, so I've copied that, but how many bubbles did I draw? 2. And that's our equation done and balanced.